Um, Imagine trying to cram a massive V8 engine right into a tiny go-kart. I mean, that is exactly what developers do when they force massive AI models onto restricted mobile devices. So today we're tackling the 810-110 exam, 60 questions, 90 minutes, 80% to pass. We are focusing on 5 crucial AI and machine learning scenarios to really get you ready. Let's just jump right into that mobile app scenario.
Yeah, let's do it. It's a massive challenge right now when you're building a mobile app. Local compute is highly restricted, and you have to pick a pre-trained model.
Right, and the options usually give you things like release frequency, response creativity, parameter count, or training duration.
Hmm.
I look at this and immediately think of security and updates, so I definitely prioritize release frequency. Am I completely off base there?
Well, I mean, it's a really common trap, honestly. Updates are great, but the single most important factor here is actually the parameter count.
Wait, really? Not the updates?
No, because release frequency doesn't matter at all if the device just crashes the moment you boot the app up. Parameter count dictates the physical footprint.
Oh, like the memory and processing speed required.
Exactly. That is your V8 engine in the go-kart. And, well, we can ignore training duration entirely since you're selecting a model that is already pre-trained.
Okay, so size dictates function on the edge. I get that.
Yeah.
But let's build on that pipeline. What happens when we have multiple types of data?
Like what exactly?
Say an analyst is reviewing a visual network topology diagram and simultaneously cross-referencing text-based configuration logs. We have a generative adversarial network, an embedding model, a diffusion model, or a multimodal model.
Okay, so what is your gut reaction on that one?
Well, my cognitive bias just screams embedding model because, they're phenomenal for similarity searches across data.
They are, yeah, but an embedding model isn't built for joint visual and text analysis out of the box.
Ah, so it's a trap.
A huge trap. To handle diverse input types simultaneously, you actually need a multimodal model.
Multimodal. Okay, that makes sense.
Yeah, it's the only true bilingual option here. I mean, diffusion models generate images. They don't analyze diagrams. And GANs are competing networks, not dual input analyzers.
Right, so multimodal is our bilingual translator. But what if we drop the images entirely?
Just text.
Yeah, let's say we just have mountains of messy, unstructured incident reports, and we need to summarize the recurring themes. We've got large language models, diffusion models, variational autoencoders, or GANs. Since we're generating a summary, I'd lean toward diffusion or maybe a VAE since they're, generative.
Oh, you are falling for the generative keyword trap again.
I am.
Yeah, diffusion and GANs are primarily built for image generation, and variational autoencoders are mostly used for reconstructing complex data, not summarizing text.
Okay, so it has to be large language models then.
Exactly. To extract meaning from massive volumes of unstructured text, large language models are specifically designed for the job. They understand context and vocabulary in a way those visual models just fundamentally don't.
That makes perfect sense. The LLM is basically the ultimate speed reader for tech tickets.
But speaking of images, what if a marketing team actually wants to create high-fidelity product images through iterative noise reduction?
Oh, I love this question.
Right. We're looking at VAEs, LLMs, GANs, or diffusion models again. Now, GANs are famous for hyper-realistic images, so that's got to be it, right?
Well, GANs are incredible, but they work by pitting two neural networks against each other. The dead giveaway in your scenario is that exact phrase, iterative noise reduction.
Ah, the static.
Yes.
Yeah.
That points directly to diffusion models. They start with pure static and gradually reduce that noise step by step until a clear image emerges.
Oh, wow. It's literally like a sculptor chiseling away a block of fog until the product appears. I love that analogy.
All right, that's exactly like that.
All right, so these tools are powerful, but how do we keep the underlying data safe? Let's say a company has proprietary source code that absolutely cannot leave its internal network.
Security is always the kicker. What are the hosting strategies? Well, we've got a cloud API with zero data retention, a managed SaaS AI platform with SOC2, a hybrid deployment, or a local LLM deployment. I have to admit, cloud API with zero data retention sounds incredibly secure. They literally promise they aren't saving anything.
Right, they don't save it, but the data still has to travel over the wire to their external cloud service.
Oh, right. It still leaves the network.
Exactly. The only way to guarantee data sovereignty for code that absolutely cannot leave the network is a local LLM deployment on internal hardware.
Ah, I get it.
All right.
A local LLM is like keeping a highly sensitive diary in a bolted safe in your basement.
Yeah, exactly.
And a zero retention cloud API is mailing your diary to a shredding company. Sure, they promise to destroy it, but still left your house.
That is the perfect way to look at it. Local means the data never leaves the building. It just eliminates cloud API and hybrid right off the bat.
Okay, we made it through the scenarios. Now let's connect the dots.
We definitely covered some vital ground for the exam. We started with selecting pre-trained models for resource-constrained applications, really seeing how parameter count rules mobile.
Right, the whole go-kart engine thing.
Exactly. Then we looked at choosing multimodal models for combined visual and log analysis. From there, we talked about using large language models for unstructured report summarization.
The ultimate speed reader.
Yeah. And applying diffusion models for high-fidelity image generation. Finally, we finished up by preserving data sovereignty with local LLM deployment.
Awesome. So as you deploy these models in the real world, ask yourself, are you optimizing for the absolute smartest AI or the smartest AI for your specific environment?